Hello and welcome to this brand new series of networking. This video is a detailed Cisco network configuration tutorial with FortiGate Firewall, and today we'll be focusing on how to design and implement a robust network ensuring redundancy and high availability. Along the way, we will cover several key concepts that forms the foundation of modern network architecture. Now, before I go ahead, I must mention that this video is intended for someone who have basic knowledge about Cisco CCNA, and this tutorial is more configuration based, but I will try to add explanation on high level basis as much as possible. Our main goal today is to create a network setup where internal traffic can seamlessly access the cloud connections, meaning the ISPs, with two ISP1 as the primary and ISP2 as the secondary, providing automatic failover in case one ISP goes down. But we will do more than just routing traffic. As we build our network, we will learn about configuring several important Cisco protocols like VLAN, VLAN trunking protocol, DTP, DHCP, rapid spanning tree protocol, EtherChannel, HSRP, OSPF, IP routing, redundancies, port security, and configuring the FortiGate firewall. By the end of this tutorial, you will have a fully functional network setup with redundancy, routing, and security, all while learning about those essential Cisco networking concepts. All right. I'm just going to bring my lab here. We are using GNS3 for the lab today, and as you can see on the topology on the screen, we have ISP1 and ISP2, a FortiGate firewall, a 7200 series core router, two distribution core switches, 4 access switches, and few client machines. During designing the IP network is also on the screen. Core switch 1 have 4 VLAN, IT management, production, Wi-Fi guest, and their SVI address for the core switch 1 starting with .10.100, 20, 30, 40, .100, right? And we also have the default gateway .254 for each of the VLAN for the DHCP pool when we configure it. And we will need this default gateway when we configure the HSRP. Right, we have the task on the right hand side, and we will go through this one by one. Let's get going and start working with the core distribution switch 1, which we will make as the VTP server and configure other switches as clients. The first task we have is to configure the dynamic trunking protocol. Before I configure, just a couple of lines for the DTP. As we know, DTP automatically establishes trunk links between switches, which are needed for VLANs to communicate across multiple switches, and it has 4 modes: access, trunk, dynamic auto, and dynamic desirable. We will configure the core switch, switch 1 as dynamic desirable, as this mode actively attempts to negotiate a trunk link with the other devices if they are on auto mode, which most of the switches are when we take them out of the box. So which links are connected to the access switches from the core switch 1? It's Ethernet 1/0 to 1/3. Okay, we can see the mode is desirable. The port were on disabled state, so I enabled the ports. There was a no shut commands that went in, and we can see that they are trunking. So time to turn the DTP on to the other core switch 2, which are linked with the access switches with Ethernet 2/0 to 3. Same thing we're going to do here. Let's change the host name, core switch 2, and then we're going to go into interface range Ethernet 2/0 to 3. And what we're going to do here, switch port trunk, we add the encapsulation .1q, and so we say switch port mode dynamic desirable. Okay, now let's do a no shot here as well in case the port is not turned on. So let's do show interface trunk. Okay, Ethernet 2/0 to 2/3 is trunking. Right, let's see what we have on the list. Create 4 VLANs on core switch 1. IT management, production, Wi-Fi, guest. Okay, VLANs are created. Next, VTP. Well, VTP allows us to manage VLANs centrally. When we set up the VTP, we only need to create VLANs in one switch. In our case, this is going to be switch 1, and it will replicate them to the other switches within the same VTP. So in VTP, we configure the mode of the VTP, which is going to be either server or client, and then we configure the VTP domain, which is also another essential one. And we're going to be configuring the version. Obviously, version by default, it's on version 2. We'll leave it alone. One more thing we can add, which we won't in this case, which is the password. So for a good security measures, the server that you configure the VTP on, it's better to add a password. In that case, when we go into the other switches within the same network, you use the same password to connect to the domain. Okay, so it says some DTP5 domain mismatch. Obviously, within the same network, the other switches doesn't have the same domain. So once we go into the other switches and configure the same domain, abc.com in these cases, they will start to pick up the VLANs that we created there. So let's go to core switch 2 and we say VTP mode client, and then we say VTP domain abc.com. Okay, so this should work. Show VLAN brief. Then you can see that the VLANs that we created on switch 1, core switch 1, it's replicating on core switch 2. So let's go very quickly to the other access switches in the bottom and then configure the VTP as client to them. Great, a VLAN replication are on. So next, configure the switch virtual interface SVI for those 4 VLANs. We will be assigning the IPs as displayed on the GNS screen. So we're targeting the configuring the SVIs for VLAN 10, 20, 30, and 40. But one second, why we need to configure SVIs? Configuring an virtual interface in a redundant VLAN network is to enabling the inter-VLAN routing, high availability, and network resilience, right? So let's do this. We go into one second, please. I'm seeing some error here. Is it old? I believe so. But for our peaceful mindness, let's see. Show interface trunk. We are trunking. That's fine. So good. Okay. That was old one before we configured the switches as VTP client. Okay, so we're going into interface VLAN 10, right? And then we are assigning the IP address of 10.100 on core switch 1. And then we will configure the VLAN 20 with 20.100, 30.100 for VLAN 30, 40.100 for VLAN 40 on core switch 1. And we're going to do the same on core switch 2. Okay, let's verify the interfaces. Show IP interface brief. See the IP address is correct? Yes, we can see that the IP addresses are correct according to the VLAN. Let's go to the core switch 2 and do the same thing there. Let's verify it here as well. Show IP interface brief. And we have the correct IP addresses. Okay, so that's SVI done. What we have next on the list, deploy the DHCP ports for the VLAN, and that's going to be on core switch 1 because this is a server out of these 2 switches, and this will have the DHCP port for the VLANs on for the client that is connected to the access switches, and this DHCP port will give them the IP addresses. Okay, what have we done here? We deployed the DHCP port with default root router to the respective VLAN, which is the .254 for each of the VLANs, which we will be needing for the redundancy configurations of HSRP. Then we excluded this one. Then we excluded the virtual interface IP from the DHCP pool to avoid any further conflict with the client machines. So we can verify the DHCP by show IP DHCP. So we can see multiple things. We can see the pools, all the 4 pools. So we've got VLAN 10, VLAN 20. I forgot the dash in between. That's okay. It's not case sensitive or it's not going to do anything. It's just a name. It's locally significant. And then VLAN 40 as well. Now we can say also show IP DHCP binding. Obviously there are no bindings here, which will be once we configure the client machine. So let's jump into the access switch 1 and test a client machine if it gets an IP address from the pool we deployed. Now notice that each of the machine here, and I designed them according to a VLAN. Now PC1 and 2, VLAN 10 and 20, then 3040, then again 10, 20, then 3040. So each of the VLAN has 2 client machines here. So let's go to the core switch 1. Which port is PC1 connected to? Ethernet 0/0. So we go into interface Ethernet 0/0, and this is an access switch port. So it's a switch port mode access, and then we allow these port into VLAN 10. Switch port access VLAN 10. Okay, so that's done. So now that we have allowed PC1 to go through the VLAN 10 and we configured the DHCP as well, so let's go jump into the PC1 and see if it gets the IP address. So DHCP, okay, that's all we need to do. We might have to do it a couple of times for it to get the IP address if everything's all right. Yeah, that seems like working fine. We're going to get an IP address of 10.1. So 10.1, the DHCP for VLAN 10, that's what we configured on core switch 1, which is the one you can see here. Now that it has the IP address, if we execute the command show IP DHCP binding, it's going to show us that 1.10, the MAC address of that machine, it's connected and it's in VLAN 10. Okay, so that test was done. I will pause the video sometime when we're doing this and configure the rest of the machine according to their access port. Putting these on in the video is just time consuming. So you have seen one port and then we can do the rest of the ports, and we will do the port security at the end of this video. So next on the list, what we have, where are we? We verify the DHCP port, we configure the access switch, test the DHCP binding, we did deploy the EtherChannel between core switches. Okay, well, EtherChannel is a tag that combines multiple physical network links like Ethernet cables between switches or between a switch and a server into one logical link. We're increasing the bandwidth and providing redundancy. Well, by grouping links together, EtherChannel creates a single high-speed connection that allows data to flow across all links in the bundle. If one link of the EtherChannel goes down, the other links continues to carry traffic, minimizing the downtime. It's brilliant. So, okay, let's configure the EtherChannel and bundle those 2 links between the core switches, Ethernet 3/0 and 3/1. We go into the configuration mode and then we say interface range 3/0 to 1. What have I missed here? Okay, that's going to be ETH, Ethernet 3/0. Okay, so we're saying channel group, yeah, 1. Again, it's locally significant. You can put any numbers here. And we're saying mode. What do we have in the mode? We have active, auto, desirable, on, passive. So 2 of the protocol that mainly used, which is PAGP, port aggregation protocol, and LACP, link aggregation protocol, which is the the industry standard LSTP, and PACP is the Cisco proprietary. In our cases, we're going to use the LACP. By saying mode active, we are choosing LACP protocol here. Okay, so it has created a mode. Now, what we have to do, we still have to form the trunk between these two switches, though they already have the trunk via the access switches, but we are creating the ether channel very explicitly between these two switch. So we're saying we're enabling the encapsulation, which is a dot 1Q, and then doing switch port mode trunk. Okay, saying no shut. Okay, if we do IP interface brief, what we're saying a port channel 1 has been created. It's down. Obviously, it's down because we haven't configured the core switch 2 yet. So again, on core switch 2, we're going interface range Ethernet 3/021, and let's keep it shut for the timing. And we're saying channel group 1, and we're saying mode is active, choosing the LACP on this part as well. Now going switch port trunk encapsulation.1Q and doing switch port mode trunk. Let's do no shut here. Okay, and they're going to come back up now. Show IP interface brief. They should be up in a second. Yep. So you can see they are up. Okay. Configure RSTP, Rapid Spanning Tree Protocol. The name says a lot, right? It significantly reduces the convergence time, unlike the STP, Spanning Tree Protocol, which goes through a series of state blocking, listening, learning, and forwarding. RSTP can transition ports directly to the forwarding state. It's brilliant, isn't it? So this allows the network to recover from changes in just a few seconds. Usually it's 2 to 3 seconds, but it depends on the kind of environment you are working with, the topology you are working with. Where the traditional STP will take or wake up in around 50 seconds for the network to converge and find an alternative path. Okay, so let's do the RSTP configuration, and we will set 2 priority for our VLANs. We got 4 VLANs, and we can allow core switch 1 and 2 have their own respective VLAN here. Okay, so let's do core switch 1 first, and we're saying here config T spanning tree mode rapid rapid PVST. So PVST is a part VLAN spanning tree. Okay, and then we're doing spanning tree VLAN. I think 10 and 20, the priority here. So the less the priority will take the precedent here, right? Okay, so 1496 adding for 10, 20, okay, and then we adding for VLAN 30 and 40. Let's see which one what we can do. 30, 40, 400. Wow, okay. So priority, let's set the priority was 8192. Yeah. So then we are telling core switch 1 to have these 2 separate priorities for VLAN 10 and 20 and 30 and 40. 30 and 40 is less prioritized in core switch 1. Okay. Now we're going to jump to core switch 2 and going into the config mode. We're saying spanning tree mode rapid PVST power VLAN spanning tree, and we're saying spanning tree VLAN. Here 30 and 40 going to be the primary route for sorry, beg your pardon, through this switch. Priority is going to be less here, 4096, 30 and 40, and then again let's change the value here at first. So we did 8192 for 30 and 40 on the other switch, and here 10 and 20. 10, 20. Okay, that's it. Well, to be very honest, this is all you need to do basically. You are dividing the traffic between these 2 core switches using these the rapid spanning tree protocol. So the traffic 10 and 20, all the 10 and 20 going to go via this core switch, and all the 30 and 40 traffic going to go via core switch 2. So it's purely configuration based, as I mentioned earlier. So I'm not going to go deep into each and every single topic because they are very broad, very big. If we start talking about them, we're going to have to make videos for each of the protocol here. Right, next, the big topic, HSRP, Hot Standby Router Protocol. We will set up the redundancy for the VLAN across 2 core switches, not forwarding all the traffic through one core switch, let's say core switch 1. And we will configure core switch 1 as the primary router for VLAN 10 and 20, while core switch 2 will be the primary for VLAN 30 and 40. Well, it sounds like rapid spanning tree protocol, isn't it? Well, yeah, similar. But in this case, for the HSRP, the higher the priority will take the hot seat. So, for example, if we say 150 for VLAN 10 on core switch 1 and 100 for VLAN 10 again on core switch 2, then obviously core switch 1 will be chosen for VLAN traffic to go out to. Okay, each VLAN interface has an HSRP group with a virtual IP address that client devices can use as their default gateway. So that's default gateway we configured during the DHCP pool configuration. If the primary switch for a VLAN, let's say switch 1 for a VLAN goes down, the secondary switch will automatically take over. Well, this configuration provides both load balancing and high availability for critical network path. So I have written down because there are 4 sets of configurations basically on each switch. So I've written down the configuration. It's going to be easier and time savings as well. What we're saying here, we're going into each interfaces of the VLAN and we're saying standby, which is the name we have to mention for configuring the HSRP, and we're saying 10. This is again locally significance, but the best practice is that if you are targeting a VLAN, then write down the number of that VLAN. Not necessarily if you can track it down with different name with a proper documentation, that's absolutely fine. But I always go according to the VLANs that I have within my topology. So standby 10 IP. So the standby IP for the VLAN 10 is the gateway that we configured, right? So all the client machine that you're seeing in VLAN 10, their default gateway will be 10.254. And then we're saying standby 10 priority 110. So we're giving 110 to VLAN 20 and VLAN 10 on core switch 1, and 30 and 40 on core switch 1 are having less priority. Here again, 30 and 40 will have 110 on core switch 2, and VLAN 10 and 20 is going to have less priority on core switch 2. Okay, so that's clear. We will just copy this and go into switch 1 interface. All we have to do is just to paste it, and then we will have an active HSRP configuration. So that's 1, and then we're going to go here. Okay, go to core switch 2. Be very careful when you copy paste configuration. It's very important, especially in the real life environment. It's really important. So let's give it a couple of seconds, and they're going to form standby, active, and standby path or router. So what we can do, we can execute the show standby brief commands and see who has taken over what kind of responsibility. We can see that it's listening, and it will go on standby mode, VLAN 30 and 40 on core switch 1. Okay, it's still listening, speaking. Hopefully we have done everything right, so give it a couple of seconds. Yeah, there you go. So it's sorted, right? So what can we see here? We can see that VLAN 10 and 20, the state is active local. So core switch 1 is the active router for VLAN 10 and 20, and VLAN 30 and 40 is the standby is the standby router here at the core switch 1. Now if you go back to core switch 2, same thing here, show standby brief. Here 30 and 40 is the active. That's what we did here, isn't it? 30 and 40 have 110 priority, where in core switch 1 it's 90. Okay, so that is HSRP. Now can we very quickly ping from one of the machine? say 192.168.10.254. Can we ping it? We can. Brilliant, isn't it? Okay, so that is HSRP for you. And next is configure the IP address between router and core switch. So that's the router, and the core switches is here. We have defined the IP subnet here, /29, starting with .1 and .9 on either side of the network. So let's jump on core switch 1. And while we're going in core switch 1, interface Ethernet 0/0. We're saying IP address, what's that? 172.16.1. This side is 2, okay? And we're saying, what's that? /29 bit network, so it's going to be 248. Did we do? Right, okay. So this is not a layer 3 port, it's a switch. In order for you to put an IP address, you have to say no switch port. There you go, okay? So if we go back, it's working fine, do no shut. That's core switch 1, and then we're going to core switch 2. Let's open the router console first, bring it here, okay? And core switch 2, again, don't forget the noise switch port and upgrading it to layer 3 switch port. So we're going to interface Ethernet 0/0. We're seeing no switch port. It's no funny business. Okay, IP address 172.16.1.10 here. Subnet mask 248/29, saying no shut. Now let's go to the core switch. Beg your pardon, core router. We are entering interface first. It's on a 0/0 first, and we are saying IP address 172.16.1.1 and /29-bit network, saying IPDD. Wish. Okay, there you go. No shut. And coming out, going back in interface Ethernet first, Ethernet /0, we're saying IP address 172.16.1.9 this side, okay, 255.255.248. Okay, no shut. Can we test for the link? Certainly we can. 16.1.2 for core switch 1. Yeah, that's fine. That's brilliant. Okay, and then 10 on this side. Okay, right. Okay, we can ping, and we have an active link between core switches and router. So next on the link, configure the OSPF between core switches and the router. OSPF is a very big topic. Okay, it's a dynamic routing protocol that enables network devices to exchange routing information, choosing the best path for data. Well, as many of you know, we can configure OSPF in two ways, either on global config mode or directly on the interfaces. Well, global, or the router mode configuration, this is a traditional way of configuring OSPF by entering router OSPF mode in global configuration. You specify OSPF parameters such as network statement, areas, and router ID. The network command here designates subnet and interfaces that participate in OSPF based on the matching IP addresses, obviously. So if we just follow the traditional method, then all we need to do is to go into the global config mode, and we say router OSPF, give the number of the OSPF and ID, and then define the network. Based on that network, whatever the interfaces has that network will be participating into that OSPF area, or the number that you define. On the other side, the interface configuration mode, this is widely used in the real life scenarios, involves configuring OSPF directly on each interfaces using interface level commands. Here you can directly specify the OSPF area and network type. Like, you can just go into the interface, let's say interface first is on the 0/0, and we can say, you know, IP OSPF IP OSPF network, beg your pardon, IP OSPF 1 area 0. So the interface will directly get into the OSPF configuration. Okay. In our lab, though, we will follow the traditional method for this area between the switches and the router, and interface mode configuration between the router and the FortiGate. Okay, so we see both the method. Okay, so let's go and configure the OSPF. We're starting with core switch 1. Okay, coming back out from the interface, we say router OSPF 1, and what do we have? Router ID is going to be, let's do core switch 1 as 1 and 2 and 3 and 4. Okay, this way. So core switch 1 is having 1.1.1. Okay, that's the ID. And we do network here. So the network is for the core switch 1, the VLAN network that we configured, which is 192.168.10.20.30. 40. Now we can't define the entire bigger pattern. We should not be doing like each and every single VLAN. And instead, what we can say is 192.168. Just allow the entire 16-bit network at the end, and we say 255.255.0.0. Let's create an area 0 for this. Okay, so there's going to be area 0 here. There's going to be area 0 here. Well, you can segregate the areas as well, but then your routing information will be additional configuration when we do it with the core router. But since it's not a different area, it's within the same infrastructure, within the same comms room, where you can say area 0 up until port 1 of FortiGate Firewall. Okay, so this first we allowed the VLAN network, then we are allowing this network that it has. Okay, so we have 1.0 network, right? But two different subnet, but 1.0 network. So saying network 172.16.1.0, and the subnet is .0, saying area 0. Okay, so that's it on core switch 1. We go back to core switch 2 and do the same thing on core switch 2. Router OSPF 1 network router ID, beg your pardon, 2.2.2.2, and adding the network, the same thing as we did on core switch 1. Okay, and again network 172.16, 1.0, 255.255.255.0, and saying area 0. Okay, let's go to core router. Coming out, saying router OSPF 1 network. We're doing the network 172.16 1.0. Okay, and saying area 0. Okay, that's it. It's just forming the network, and let's see what we can do. Show IP OSPF neighbor first. We can see 1 and 2, both of them are here. This is still listening each other, so do show IP root. We can see that we did not add this network in the core router, right? But it's listening them via the OSPF network, because these two core switches have this network. In the if we do show run section OSPF, right? So if we do this, we added only one network here in area 0, yeah, but the router is learning the network OSPF network, which is the VLAN interfaces via the OSPF active listening mechanism. Okay, so that's OSPF in very brief. Now we can do OSPF for a very long time. There's lots of things when you do the NCore or you go into the CCIE topics. There is a very massive big chapters about OSPF, and you'll be spending hours reading and configuring the OSPF. So what's next? We have configured the IP on router interface towards the FortiGate. Okay, so towards the FortiGate, let's see the router here. We go in interface, which is gigabits 1/0. Gigabit 1/0. We're saying IP address. What did we define here? The IP address /30 network 192.168.0.0, and this side is 1. So 192.168.0.1, and this is 252 subnet, which is /30 cider. Okay, and doing no shut. That's done. And let's do this. What's next? Configure the IP address interfaces. Okay, so I kept the FortiGate configuration at the last. So we have to do the IP address assignments on ISP 1 and 2, gigabits 1/0 on both router, and then we have to create a loopback interfaces for each of the ISPs which we will be targeting to reach from the client machines down here. Okay, so let's jump to ISP1, ISP2. Okay, so for the ISP1, going into interface gigabit 1/0 and saying IP address 20.20.20.2, that side. Okay, sorry, that's the subject mask, it's 248. Okay, no shut, come out. So do interface loopback 1. Let's do an standard DNS type loopback interface and full subnet. Okay, no shut. Have it, though it's it doesn't need no shut, but yeah. Okay, that's ISP1 and ISP2. Okay, config T interface gigabit 1/0 IP address 10.10.10.2. Again, 29-bit network. What have I done? If I can only type. Okay, that's fine. No shot. Come out. Create another loopback interfaces here. Same 8.8.8. Interface loopback 0. IP address 8.8.8.8. And then we're doing 255.255.255.255. Okay, that's done. Okay, and well, this concludes these two tasks: configuring ISP interfaces and create a loopback interface on each ISPs. Well, time to configure the FortiGate. I haven't logged into the FortiGate yet, so the password would be a default one, I guess. Yeah. Okay, that's fine. So what we're doing, first thing, we're configuring the IP address towards the core router interfaces. Okay, so core router is this one, which is in port 1. So how to do it? Config system interface. Okay, and you can go, the FortiGate works brilliantly. Well, you can either go into the web interfaces, or you can do the command line. I love the command line, so I do most of the things in the FortiGate from the command line. So if you do show going into each of the configuration or the modes that you are on, then it's going to show you that what it has. So we have got port 1, port 2, port 3 here. Okay, and what we're targeting, port 1. Okay, so what you need to do, say edit port 1, which is pretty easy and handy. So you say edit, okay, and port 1, okay, and then you go into the port 1, you say show, do you have anything? So we see that what we have. So first thing we need to change, as I can see, the set mode is DHCP. So we say set mode, not DHCP, we want static. Okay. The next thing we need to do is to set IP addresses. Set IP. You don't need to say add here, like this is Cisco, it's different. So we are saying 192 is port 1, remember? Yeah, so it's this network. 192.168.0.2 and add the subnet mask. So 252. You don't need to do no shots. If you want to save the configuration, yeah, by default it's all up. If you want to save the configuration, you just say next or end. Now, a few things that one more thing that I need to explain here, that you need to set the allowances here. So I can see that ping and HTTPs are already allowed. If you want to add more protocols, it's completely up to you. Like all you have to do is to set allowances. Yeah, you say ping, HTTP, HTTPS, SSH, you know, just go on and on. So next, you say next. Once you do next, it's going to come back one step, say on the interface configuration mode. If you do end here, it's going to save it. Okay, but we're not doing end because we need to configure port 2 and port 3. So we say edit port 2, right? So we say set mode. Obviously, we have to change the mode to static, and we say set IP. So port 2, which is here, towards the ISP1, we say 20.20.20.1 this side, right? Okay. 255, 250, 248. Okay, so be very careful when you're entering the IP addresses. Okay, and then we say set allowances, HTTP, HTTPS, ping, SSH, all this protocol, whatever you need according to your requirements. Okay, coming back up again on the interface configuration, we say edit port 3 now, which is the ISP 2, right? And what we're doing, set mode static, and we're saying set IP address. Oh, I wish IP address. So 10.10.10.2 beg your pardon, not 2, it's going to be 1, and then 255.255.240, this time. Set alarm says ping, HTTP, HTTPS, SSH, next, and then once you say end, it's going to save the configuration here. Okay, show system interface. If you do that, you'll see if your IP address is correct or not. Port 2, this is what we set, right? Now you can do execute ping. If you want to do the ping, you have to do execute ping. Let's ping a core router first, 0.1, right? We have the connection to core router. Let's try 10.10.10.10.2. Okay, that side is fine. Let's do 20.20.20.2. that side is fine. Now can we ping the loopback interface from the firewall? Can we? No, we can't, because there is no static route telling the FortiGate that, oh, you can reach to the internal interfaces of the ISP. There is a direct connection there that is between the ISP gigabit 1/0 and port 2 of the FortiGate firewall. Okay, now what do we have to do? We have to configure the OSPF. Now we're going to do point to point instead of the traditional way of configuring the OSPF. Okay, let's do we haven't done the OSPF in this interface yet. Okay, so let's do the OSPF on, let's do it on the core router first. Okay, so we're going into, well, we are already in this interface, but let's add the router ID first. Okay, IP, router OSPF 1. We already added this, isn't it? So let's do a quick section OSPF. It has the router ID. Yeah, OSPF 1, that's fine. One sec. Show IP OSPF neighbor. Ah, right, okay, so we haven't added the router ID, and it's listening as an IP address. If you don't do this, it's just going to listen the IP address and make it as a OSPF ID. So let's go under config T and say router OSPF 1 and the router ID. We said it's going to be 3, isn't it? So 3.3.3. Okay, so let's do clear IP OSPF process, right? Okay, did we say yes? Okay, that's fine. So it's just going back, going down, and coming back up, loading everything. Okay, so in the meantime, we can go back to interface now. Yeah, interface gigabit 1/0, and this time we're saying IP OSPF 1, and we're saying area 0. Okay, so while we are saying it, we are going into this interface and we're saying area 0, not these two, because they are configured traditionally between these two objects, right? So this. Now another important line here, IP OSPF commands, beg your pardon, network point to point. We're saying point to point network between core router and then FortiGate firewall. Okay, so that's it here. Now obviously it doesn't know, you can't form the neighborship with the FortiGate unless we configure the FortiGate router. So how do we do it? In the FortiGate we say config router OSPF. So once you go into that, again, similar like the interface configuration, you can say show, do you have anything? We don't have anything. So we can set the router ID. Okay, it's going to be 4.4.4. so this is 1, 2, 3, and then now FortiGate will have 4.4.4. how many 4 did I do? 1, 2, 3, 4. Yeah, that's fine. Okay, and then what we're doing config area here. Okay, so we're saying config area, and then we're doing edit. Okay, if I can edit 0.0.0.0. Now in FortiGate and the other devices using standard OSPF configuration, the notation .0 is used to represent the OSPF area 0, the backbone area, instead of just 0. For the consistency and clarity of the configuration. In the Cisco environment, we have the luxury to use a single digit, but here, this is what you need to do. So we have added the entry 0, that's going to be the OSPF area. So we say and come out, go to the main OSPF configuration mode. We configure the network here. We say config network first. Okay. So what do we have in the network? Nothing. So we add one. So we say edit one. We say this in OSPF in the Cisco. What did we do? We say subnet, right? But here we say prefixes. Okay. If you are unsure at any stage here, you just can do question mark. It's just going to say what configurations are available here. So see, we're doing set here, set prefixes instead of subnet, and we are adding 192.168.0.0. Okay, and then the subnet mask. So what subnet is this? Sorry, it's not 0.0. It's going to be yeah, sorry, 0.0. That's fine. So this is the subnet between the core router and the FortiGate. Okay, so we're adding the prefixes here. Now we define that this network belongs to area 0. We have already added the area in our database, so now it's going to accept the command. Now if you configure the network first and then you try to add the area, it's not going to accept it. So you're going to have to configure the area first and then go and add the network. So that's that. Now if we do next is come out of the network interface and then we end it, then it will save the network configuration. Now remember that the gigabit 1/0 on core router is configured as point to point, right? So we're going to have to define the interface type. The OSPF type is point to point using the interface. So we go into config config interface, right? So what do we have here? We have nothing. But what can we do? We can do this when we do a question mark, right? So we do edit, right? And then we add a remark port 1. Port 1 is not actually port 1. We are here just giving it a name. We will add the port 1 when we set the interfaces, okay? So it's just adding port 1 as an entry in the table, okay? So when we do this, we say set network type. So we do set network type point to point, okay? Simple. And then we're saying the set interface, so point to point, which interface? So since set interface port 1, I want port 1 to be point to point, okay? That's it. So that's all. We save it here, and then we come out of the interface, and then we come out of the OSPF as well. Once you press end here, execute end here, the OSPF configuration will be saved. Now you can say show router OSPF. All the configuration will be available here. What you did, we set the router ID, we configured the area, and then we configured the OSPF interface. We added the interface port 1, which is here, and then we set that interface point to point. Again, we add the network, and the network is 0.0. Okay. Now, can we, if we do, the show IP OSPF command in Cisco environment, here it's show router info, and then you say routing table all. Okay, then you can see that all the information is available or not. Core router has learned the VLAN traffic via the OSPF configuration between core switch 1 and 2, right? Also, when he forms the neighborship with the FortiGate, he advertised it automatically, is redistributing it automatically to the port 1. When we go into the routing thing, we want the VLAN traffic to be able to go past the firewall to ISP 1 and ISP 2. In order to do so, what we have to do is to do an IP routing here, a simple IP routing the network, and we say the next hop is port 1. Then that's fine. So a couple of more things left here. What did we do on FortiGate so far? We configured the interface, number 1. And then we configured the OSPF. Now, obviously, OSPF connection between these two are live. We can see this by here. If you want to do that, you can do get router. One more important command here: get router info OSPF neighbor. That's what you can say. Okay, and you can see 3.3.3.3, which is the core router, and via the interface port 1. The most important part in the Cisco firewall is to configure the firewall policies. If you don't have a policy, the FortiGate doesn't know what to do with your traffic. So you need to configure the policy, set the policy right, and then redundancy and the static route can come after that. Only then your traffic would be able to go past the FortiGate to ISP1 and ISP2. So let me very quickly configure the firewall policy, and I'll explain what I did and why I did that. Okay, so I have added a few of the entries here in policy number 1 in the first field. So what are they? So the first thing I did is the set name. I said, why did you say set name enable 1? So that's not, I did set name inside to ISP1. Okay, yeah, there you go, it's changed. So name is indicating it is for traffic from the internal network. It's just a name I'm putting here. So for my own recognition and document purposes, I'm saying inside. This first policy is inside to ISP1, the first one, okay? And then what did we do? We said source interface. So the traffic comes from port 1 here. The traffic comes from port 1, okay? The next one is destination interface. Which way the traffic gonna go? If the traffic comes in through the port 1, it's going out to port 2. And we're saying set action accept. So set action accept is usually that whatever the actions is coming in, you accept everything. The policy accepts the traffic basically. So meaning it allows the traffic from the internal network to reach to ISP1. So then source address, what are we saying? It's a source address, we're saying all. Well, now you can, when you go deep into the FortiGate configuration, and depending on your requirements, your source address can be different. Now, you probably have internal network that you don't want to send them out to the cloud. So you can define the source address accordingly, setting different source addresses. In our cases, it's simple. We're saying source address all. So we're saying destination address. Again, the policy applies to all destination addresses, meaning it allows the outbound traffic to any destination. You can, always change it, block the sites, block the different domains. It's completely up to you, because this is FortiGate we're talking about. There are hundreds and hundreds of configuration in there for you to configure. What did we say? Destination address? Yeah, so talked about the destination address. The schedule allows. Well, the policy is always active, right? So by saying always, we're saying the policy is always active, meaning it is not time-based and applies at all times, right? So similar kind of configurations is available in the ASA environment if you go in there, but there are full length of commands if you want to the scheduling, the SLA scheduling. If you have done the the ASA firewall configuration, then you'll see that you set the SLA and then you say, the lifetime scheduling it like always. So that's that. Service all. Look at this. The NAT is not here. It's the most important part. Set NAT enable. Okay. That's it. Do a show again so I can see shots. NAT is here. So NAT, we know network address translation. If NAT is enabled, meaning the source IP address, whatever comes from core router, the source IP address will be translated to the external IP addresses. This is what NAT does. I mean, it's if you have done your CCNA, then you would know what NAT is and how it works. I mean, what's the purpose of NAT? Then yeah. So again, whatever the traffic comes through port 1 is going to be translated to the external port accordingly. Clear? Brilliant. So last but not the least, let's just save it first, okay? So we say, did we say next? Policy, yeah, next, and we end it. We save the policy. If you want to see it, you again show firewall policy. If you do that, you can see your before I forget, I was just talking, I forgot to add the other policy for the ISP2. Okay, so we say config firewall, yeah, not filter mate, firewall policy. We do edit 2. We did edit 1, right? Now we're doing edit 2, and the same configuration in there as well, apart from these. Okay, but everything else is same, whatever we have done here, right? So let's copy this. Yeah, go back in. This is our configuration. So we do here, let's close this one, we don't need it anymore, and change the port 2 to port 3. Okay, and the UID, we don't need this, is going to give us an UID automatically. So rest of the things is same. So let's copy this. Okay, and then on edit 2 we execute this. Okay, and we say end. Now if we do show firewall, show firewall policy, we have got 2 of them enabled here. Let's just very quickly verify if we have all the entrants. Look at that, excuse me, so we don't have the name here. That's very important, right? So config firewall policy edit 2, right? So set name, what we're doing, inside to ISP2. Okay, now next, and show firewall policy. Okay, we have it, ISP2, that's fine. Port 3, port 2, that one, first policies. So 1, 2, 3, 4, we're saying source interface, destination action, source address, destination address, schedule always, that's fine. Action, source, destination, that's okay. Okay, last but not the least, see our list actually, it's better. So configure the static route. Okay, so if we do the static route, then we'll be done. So what we're doing is static route. So we say again, same thing, config router static. Okay, so we're telling the firewall which way you need to go to find the outside network. So we're saying here, let's same thing, edit 1, just like the firewall policy. We're saying set the gateway. We're saying your gateway should be interface 2 via the port 2, right? So we're saying 20.20.20.2. That's the IP address over there. Okay, so here, and then we say set device. Yeah, set device port 2 is that way you need to go, mate. Okay, so that's the first policy. Now add the second one. This is the redundancy we're talking about here, right? If one fails, you go to the next way. But then there is a way that you can define this. By default, you set distance if you want to create the redundancy between 2 ISPs using the FortiGate. So by default, the distance is 10. Okay, so if you don't set a distance, for example, the edit 1, what we did for ISP1, we didn't set the distance, so by default it's going to be 10. Now if we do edit 2, right, we say set gateway, and then we say 10.10.10.2, right, and we say set distance here 20. So this is going to be secondary. The higher the distance, the lower the distance is going to be the primary, take the precedence, right? Set distance 20. Which way is going to go? Set device is going to go via port 3, that's ISP 2 for us. Okay, next, and we save the configuration, right? Okay, so that concludes the static routing configuration in the FortiGate. So now that we have configured the firewall policies, interface configuration, OSPF, and we have set the gateway, the redundancies configuration in the FortiGate, can we ping from PC1? That's a question, right? So moment of truth, we can go to PC1 and try to ping the loopback interface. Let's see if it pings. It doesn't. Well, it doesn't because the ISP, the core router is not forwarding the traffic, whatever he's receiving. Obviously, on his OSPF database, all the subnets are there, right? So if we do show IP interface brief, then show IP OSPF. My mind is actually quite tired at the moment. Show IP route. So that's what I wanted to do. Initially. So we can see that the router lands the VLAN subnets using the OSPF mechanism. Now, it doesn't have any static route, or it doesn't have any sorts of other mechanism that can define, okay, whatever the traffic you receive, forward it to FortiGate. Okay, So what you're going to do, we're going to set in static root. We're going to say IP root. So the subnet that whatever you have, forward it to FortiGate. What's the IP address for the port 1? It's 192.168.0.2. Once we do that, we can go back to PC1. We'll try to ping again. Voila, there you go. It's working fine, isn't it? So that is our main motto, that we should be able to ping from the VLAN traffic. Now that's VLAN 10. Let me just quickly show you from a different VLAN. So we are accessing to access switch 2, and let's configure the interface Ethernet 0/0, which is in VLAN 30, right? So switchport mode access, switchport access VLAN 30, right? Okay, let's open PC3 and we do DHCP. There you go. Okay, so we got 30.1 here. Can we ping the loopback interfaces? We can. Okay, now that we can ping from different VLAN to the loopback interfaces, and we talked about the redundancy. Now, if one of the ISP goes down, okay, well, what's going to happen? Let's take down port 2, see that if it works. That's the primary, isn't it? Our primary goes down. So if we go back to FortiGate, and if we do config system interface, config system interface, and port 2 is so edit port 2. Okay, and then what we're saying set status status down. Okay, now that we have taken down the port 2, which is the ISP1, the primary ISP1, can we go back to PC3 and try to ping it? We still can ping now, but it's going to the ISP2, even though the ISP1 is down. The traffic is going to ISP2. Okay, so that is redundancy for you, ladies and gents. Now, before I conclude these, I just quickly want to touch base on a few of the topics. So, RSTP versus the HSRP. We did RSTP configuration, the Rapid Spanning Tree Protocol, and then HSRP. So what's the difference really between them? Because they both are forwarding the traffic and doing the load balancing thing, right? So spanning tree protocol and hot standby router protocol both improve the network reliability, but have different roles. So RSTP operates at layer 2 to prevent the network loops in a switch-based environment by maintaining a single active path and quickly rerouting traffic if a link or switch fails, thus ensuring stable data flow within the LAN. Now, HSRP on the other side operates at layer 3 to provide gateway redundancy. So we have the gateway .254 by allowing the multiple routers to share a virtual IP address. In the event of a router failure, one of the switches, either core switch 1 or core switch 2, HSRP switches traffic to a standby router, maintaining a continuous network access for connected devices. Again, while the RSTP ensures loop-free paths, HSRP guarantees an uninterrupted default gateway for outbound traffic. So another topic that I wanted to touch base is, could we remove the core router, this one, and directly connect the core switch 1 and core switch 2 to FortiGate Firewall? Well, in theory, yes, obviously, why not? But this eliminates the core router and have the distribution switches connected directly to the FortiGate. The FortiGate would need to handle all the routing, the inter-VLAN routing, the external routes, and the default gateway function. This could be done, but it would require careful configuration, particularly to ensure the high availability and proper routing. If the FortiGate fails, it could bring down both internal and external traffic unless you implement a high availability feature for the FortiGate itself. In practice, the core router typically remains in place for more robust and scalable routing, as it handles the complex routing logic, while the FortiGate acts as the security and external firewall gateway. Okay, I guess that was the things that I said I would cover apart from the port security, which I intended to do at the end. But I'm thinking of making another video about security within the same topology we worked on. So there will be another video for all the security or possible security protocols and setup that we could do uh, using the same kind of layout. So what I want to say, apologies for a bit lengthy video. I wanted to accumulate most of the thing in one place, and this is intended solely for educational purposes. But obviously, if you have any questions, feel free to drop it in the comments. And until the next video, I would like to thank you very much, and I hope this was informative for you.